Imagine standing on the deck of a ship in the Arctic. At sunset, the water is a deep, dark blue, churning with waves. You go to sleep, and 8 hours later, you wake up to a world that has turned silent and white. As far as the eye can see, the liquid ocean has become a solid, glassy sheet. It looks like magic, but it's actually one of the most intense physical transitions on Earth. This isn't just ice. It's a massive thermodynamic engine switching gears.
Behind every moment lies a scientific wonder. I'm Kale, and welcome to SciCurios, where curiosity meets science.
How does billions of gallons of salt water turn into a solid floor overnight? Freezing the ocean is much harder than freezing a lake. Salt is a natural antifreeze, pushing the freezing point down to about minus 1.8 degrees Celsius. But when a polar vortex drops temperatures to minus 40 degrees Celsius, the ocean enters a state of supercooling. First, billions of tiny, needle-like crystals called Frazil ice form. They are so small they make the water look oily or greasy. Sailors literally call this grease ice. If the water is calm, these needles knit together into a thin, elastic skin called nilus. It's so flexible it actually bends with the waves. But if the sea is rough, the ice bumps into itself, creating circular, raised edges. We call this pancake ice. It can cover thousands of square miles in a single night, turning a liquid playground into a jagged frozen desert. The moment the ocean freezes, the planet's air conditioning kicks in a high gear. This is called the albedo effect. Dark open water absorbs about 90% of the sun's heat. But the second that overnight freeze happens, that white surface reflects 80% of the sun's energy back into space. By freezing overnight, the ocean isn't just changing its state. It's actively cooling the entire planet. It's a self-reinforcing shield that keeps the poles cold. For the animals living here, this overnight freeze is a race for survival. Polynyus, holes of open water, become life-saving breathing spots for whales and seals. If the ice closes too fast, they can become trapped. For humans, it's a navigational nightmare. A shipping lane that was clear at dinner can be an impenetrable wall by breakfast. We are talking about ice growing at a rate of several centimeters per hour under the right conditions. The overnight freeze is a reminder of how quickly our environment can shift when the right variables align. It's a beautiful, terrifying transition that regulates our global climate. But as our oceans warm, these overnight wonders are becoming rarer, and the dark, heat-absorbing water is winning the tug of war. So, here's a thought. If the white shield of the Arctic disappears, can we ever truly replace the cooling power of the overnight freeze? Drop your theories in the comments. I'll be jumping in to discuss the science with you.
Science is everywhere if you just know where to look. Thanks for watching SciCurious. Until next time.